4.2 Solving applications with system of equations. So back in 2.2 we solved linear equations type of problem, and in that session we use only one equation. Some of the problems can be used in one variable, and then some of the problems can be used two variable. So in this session we will mainly focus on using two variables for the unknowns and set it up a system of equation to solve. Like before, board problems I want you to do in 4-step format. 1. Assign the variable for unknown. 2. Set up the system. 3. This time we're going to be solving the system by either substitution method or elimination method. And then lastly, we'll be interpreting. So we will look at different types of problems in here. The first type of problem are direct translation type, meaning you don't need to use a formula. You can just translate from the problems and then set up the equation. So let's take a look at on the example number 1. Okay. So take a minute to read the example number 1. So Canon currently sell suit for company A at a salary of $22,000 plus a $10 commission for each suit is sold. And company B offer him a positions with a salary of $28,000 plus $4 commission for each suit sold. So how many suit will Canon need to sell for the option to be equal? Right? So in this case, our unknown is the numbers of suit that needs to be sold for company A, and the numbers of suit that need to sell for company B. So for this case, step 1, let A be equal to the number of suit, right, need to sell, and let S be the total salary because that's what we don't know either. Depending on how many suit you sell, each company will have a different salary. So I need to know a total salary. So from here, my second step, I can set it up the equations, which is the total salary for company A, that will be equal to 22,000 plus 10 times the numbers of suit that's sold. For company B, will be the total salary is equal to 28,000 plus 4 times the total numbers of suits itself. So that will allow us to see how many suits that need to be sold so that the salary will be equal to each other. So from here, we're going to set it up. We will solve this system by substitution because both of them is isolated S already. So I can say that 22,000 plus 10A, that must be equal to the salary on the other company, which is 28,000 plus 4A, which will allow us, right, to solve this quickly, subtracting 4A on both sides. So that will become 22,000 plus 6A equal to 28,000, and then subtracting 22,000 on both sides, that will give me 6,000, and finally divided by 6 to both sides, that give me 1,000. Now, the questions only ask you how many suits that need to be solved so that the salary will be equal. So the question only wants the numbers of suits need to sell. They don't want to know what is the total salary. So we don't have to complete on solving this system. We can stop right here because we know what is our A value is. So therefore, I can do the interpretation step 4 and say that I need to sell, right, 1,000 suits. So that is the difference between solving a system of equation and then solving application. Because solving application, if we got up to what we want, we don't need to continue solving anymore. That's how you're going to be saving time on the test as well. Okay. So now let's move on to the next example. Right? Next example, example 2. So Erwin spent 30 minutes on the rolling machines and 20 minutes lifting the weight at the gym, and it burned 430 calories. During her next visit the gym to the gym, she spent 15 minutes on the rolling machines and 10 minutes on lifting weights and burns 600 calories. So how many calories did she burn for each minute on a rolling machine, and how many calories did she burn for each minute for weightlifting? So in this case, my first step, the unknown, is we don't know how many calories burned when it's on a rolling machine. So we will say that first will be calories burned, right, per minute, because it's going per minute, on what? Rolling machine. Or you can write it down like, calorie burns on more rolling machines. I will accept that on the test. The more specific is better. So let's say that is R. And if you write the whole sentence, the next one, you don't need to write it again. I can say that, okay, calorie burns per minute on what? Weightlifting. That will be, let's say that W, right? Per minute. So my second step equation will be setting up the calorie burn for each visit. So the first visit to the gym, she spent 30 minutes. So 30 times calorie burns on a rolling each minute, that will give me how many calorie burns. And then plus 20 minutes, that's weightlifting. So 20 minutes time, the numbers of calorie burns per minute on weightlifting will give me, again, a total um, calorie burns. These two combined together, that should be equal to 430. So similarly, for the second visit, we have 50 minutes of rolling and then 10 minutes of weightlifting. That is a total of 600 calorie burns. So with this system of equations, we can solve for it. So step 3, and for this problem, it will be the best to use elimination method to solve the system. So I'm going to multiply the second equations by -2, which will give us eliminate the variable w. So continuing this, 30r plus 20w equal to 430. Multiplying by -2 will give me negative 100r minus 20w is equal to negative 1200. Now we add these two equations together, right? Adding these two equations together, that give us negative 70R, and W is eliminated already, right? 1200 take away 430, that give us negative 770, and if you divide both side by 70, that will give me 11. So now we got 11 calorie burns for each minute on the rolling machines, but we also need to know the weightlifting. So therefore, substituting this result into one of the equations, so I will choose the first equation, 30R plus 20W equal to 430. So 30 times 11, right? 30 times 11, substituting uh, the variable R, which is 11, and then plus 20W equal to 430, so which is 330 plus 20W is equal to 430. So 20W subtracting 330 to both sides, that will become 100. So therefore, W will be equal to what? 5 after you divide by 20. So finally, I can do the interpretations. My step 4. Now, step 4, I can say that uh, 11 calories, right, burns on rolling machine, and 5 calories. I should more specifically say per minute, right? Per minute burn on weight lifting, right? So let's move on to the next example. So the next type of example will be dealing with the geometry applications. Okay? So for geometry type of problems, you have to remember what is a complementary angle means. That means like two angles added up to be 90 degrees. Supplementary angles, two angles added up to be 180 degrees. And remember that the interior angles of all the triangles added up to be 180. And also formula for the rectangle, square, circle, and etc. Right? All the other formulas that we need to know. So those, we talked about that in section 2.2 before. So let's take a look at on the very first example of this geometry type. So example 3, the two angles are supplementary. The measure of a large angle is 12 degrees more than 3 times the smaller angle. Find the measure of the angles. So right away, when we say supplementary angles, right? When we say supplementary angles, uh, we basically know there should be two angles added up to be 180. So my unknown in this case, step 1, will be large angle and then small angle. That's our unknown. So you can say that it will be X and Y or L and S, whichever. Now, these type of problem is slightly different than the previous two examples because the previous two examples tell us translating and then get the equations right away. Right here, we need to know, all the properties, theorems, formulas in order to be able to set it up. So since these two angles are supplementary angles, right away, only if you remember the definitions, then I can say that my first equation will be the measurement of a large angle plus the measurement of small angle will be equal to 180 degree. If you don't remember the definition, then you cannot set it up the equation like this. Okay, so it's important to remember the theorems, definitions, formulas for these type of problem. How do I set up the second equation? And it's said that the measure of the large angle is, so that means the measure of the large angle is equal to 12 degree more than 3 times the smaller angle. So 3 times the smaller angle and then 12 degree more. So that is another sentence that allow us to set up the equations right here. So now we can use this to solve for it. So step 3, solving it, and you can see that this system of equations, one of the equations already solved for y, so it will be the best to use substitution method. So I will be substituting, let's solve it right here. So I'll be substituting into the first equation. So it will be x plus y is equal to 180. So therefore, I'm going to be substituting x with 3y, right? 3y plus 12 for x. And then that will give us plus y is equal to 180, which is 4y plus 12 is equal to 180. And dividing by 12, subtracting 12 to both sides. So 180 take away 12, that gives us 168. And then you divide both sides by 4, which gives us 42. Right? Now, since the question is asking you find the measure of the angles, so right now we only get the small angle because y is representing the small angle, and we need to find out what is my large angle. So substituting this value into x equal to 3y plus 12, so x equal to 3 times my y value is 42, right? And then plus what? 12. So x is equal to 3 times 42 is 126 plus 12, which is going to be 138. So finally, I can do my step 4, which is interpretations. I can say that large angle is represented by x, so it'll be 138 degree, and small angle is 42 degree. And this will be my final answer for this example number 3. So let's take a look at on example number 4. Okay. So example number 4, it tells us the measure of one of the small angle of a right triangle is 18, less than twice the measure of the other small angle. Find the measure of both angles. So we can sort of visualize this. Here's a right triangle. A right triangle, one of the angles is already 90 degree. So we have two small angles right there. So I can say that one of them is angle X and then the second one is angle Y. On the test, I don't want the picture. Pictures only help you to visualize it because a lot of times you cannot draw pictures, so you have to use abstract idea, assigning the variables and then interpreting correctly. So I can say that now my first step will be first small angle and the second small angle. Let's define it that way, X and Y. So We know that in a triangle, all the angles added up to be 180 degree. So first small angle plus the second small angle plus 90 degree, because this is a right triangle, is equal to 180. That's how I got the first equation. So you notice that in the problem, it never tells you three angles added up to be 180 degree. You have to remember that theorem. Now, the second equation is, like in previous example, there's a relation between these two unknowns, the first small angle and the small angles. This is where it's set right here. See, the first small angle is 18 less than twice the measure of the other small angle. So I can say that the first one, x, right, is equal to twice the measure of the other small angle, and then plus minus what? 18, because 18 less than that. So now this allows us to solve the system again, since this is already solved for x on one of the equations. I can use substitution method. So I will start with x plus y plus 90 degree equal to 180. Subtracting 90 on both sides, that will be x plus y is equal to 90. And we're going to substitute this equation, right, into this equation with x. So my x is basically 2y minus 18, you know, plus y is equal to 90. So this gives us negative 18 plus 3y is equal to 90. And adding 18 to both sides, that'll give me 3y is equal to 108. And dividing by 3 to both sides, it will be 36. Now that we got y already, I have to find out what is my x. So I substitute into this equation, and substituting y with 36, that gives us my x is equal to, right, 36 times 2 is 72 minus 18. So 72 taking away 18, that is 54. So finally, we can do the interpretation. My last step, step 4. First small angle, right? The first small angle is representing x, so that will be what, 54 degree. And second small angle is the value of y. In this case will be what, 36 degree. And that will be the conclusion for my fourth example. So let's move on to the next example, right? Example number 5. So example number 5, Mario wants to put a fence around the pool in his backyard. Since one side is adjacent to the house, he only needs to fence 3 sides. So that means, let's take a look at a picture. Here's a house, right? And he wants to put the fence around the pool, and then those fence is only 3 sides, because one of the side is the house. There are 2 long sides and 1 short side that is parallel to the house. Oh, so I drew the picture a little bit wrong, right? I should read it, the whole question first. So that's why always important to read the whole questions before you start, so that you can get the picture, the whole picture. And then he said that he needs 115 feet of fencing. That is basically talking about the perimeter, right? Because these 3 sides will become 115 feet. And the length of the long side is 10 feet less than twice the width. So let's say this is the length and this is the width. So now I can start this, right? So the length of fence equal to, I should say rectangle fence, right? Should be equal to L, and the width of the rectangle fence will be W. So we know those two. And second step, set it up equation. So it said that the total fence that is required is what? 115 feet. Since we only have 3 sides, I cannot use the formula 2 times the length plus 2 times the width equal to perimeter, right? Because we don't have 4 sides, we only have 3 sides. So now I have to adjust my formula, which is, in this case, I have 2 length plus only 1 width. That will be equal to what? 115 feet. That is the perimeter. And the second equations allow us to uh, set it up by the relation between these two unknown, like in previous two examples. So notice that right here, the length of the long side is 10 feet less than twice the width. So that's a relation between the length and the width. So the length is basically equal to twice the width and then 10 feet less. So now we can solve this system by, again, substitution method, which is 2L plus W is equal to 115. Oh, my bad. You see that? I copied it wrong. It should have been 155, not 115. So make sure you change that. Okay. And then I'm going to be substituting the length with 2W minus 10. So 2 times the length is 2W minus 10, substituting, and plus the width equal to 155. So it's distributing it, that will give me 4W minus 20 plus W is equal to 155. And adding up like terms on the left hand side, that will be negative 20 plus 5W is equal to 155. Adding 20 on both sides, 5W is equal to 175. Dividing both sides by 5, that will become 35. Right? So 35 times 5, that is 175. Correct. Finally, I want to find out what is my length. So substituting W into this formula, length is equal to 2 times the width minus 10. So the length is equal to 2 times 35 minus 10, which will give me the length is equal to 70 minus 10, which is 60. So finally, I can interpret it. Step 4, length of the fence, rectangular fence, is 60 feet, and the width of the rectangular fence will be 35 feet. And that will conclude this example number 5. Continuing it, uniform motions applications. So this is not new because we have seen this type of problem before, right? The formula is the distance equal to rate times the time, right? That's the main thing that we're going to be using. And also, we're going to have to look at some applications later on. So, first example, Michelle left Detroit on the interstate driving south toward Orlando at a speed of 60 miles per hour. And then Clark left Detroit 1 hour later, traveled at a speed of 75 miles per hour, following the same route as Michelle. So how long will it take Clark to catch Michelle? So in this case, they don't know the time because one person leave early and one person leave late. So I can say that step one, right? The time took for Michelle, and then the time it took for Clark. So let that be M, and then let that be what? C. So continuing set up the equations, right? Step two, and we know that Clark has to catch up Michelle, so the distance that they drive will be the same at a certain point. So Michelle is driving 60 miles per hour, so that will be what? 60 miles per hour times with the time that Michelle go, that will be M. That distance is equal to 75 miles per hour, which is how fast Clark is driving, times with the time that it take Clark to catch up. So these two distances are equal. So the first equations, we are set it up on the distance, right? So we got the distance already. And the second equations, we will set it up on the time part because there is another relation between the times in this case. So look at right here on the second sentence, it said that Clark, right? Clark left the Detroit 1 hour later. So that means Michelle drive, the time that Michelle take is 1 hour more. So when we set it up the equations, this will become the time that Michelle drive that must be equal to the time that Clark drive plus 1 hour. So that give us how long does it take, right? The time, set it up on the time. So now we can solve this equation by substitution method, right? So substitute back into the first equation, 60m is equal to 75c, and we're going to be replacing m with c plus 1, so that will become 60 times c plus 1, that is equal to 75c. So continue solving this, it will be 60c plus 60 is equal to 75c. Subtracting 60c to both sides, that will become 60 is equal to 15c. And dividing both sides by 15, c is equal to 4. So therefore, I can find out m, which is m is equal to c plus 1. So therefore, it will be equal to 4 plus 1, which is 5. Now, we can interpret it because it asks how long would it take Clark to catch up Michelle. Oh, see, we should read the questions very detailed because it's only asking for how long does it take for Clark to catch up. So I don't even need to find this portion. So finally, I can interpret it, which is need 4 hours to catch up. Right? Need 4 hours to catch up. So I would recommend you read the questions very detailed, right? So that way we won't have to do this kind of unnecessary part and then take waste time on the test. So next example, example number 7. So in this case, like we are talking about upstreams, downstreams, and stuff. Right? So let's take a look at this. A Mississippi River boat cruise sail 120 miles upstream for 12 hours and take 10 hours to return the dock. Find the speed of the river boat in the still water and the speed of the river current. So they are asking for two things. So in this case, step 1, uh, we need speed of boats in still water. Let's say B, and we need the speed of the current, right? That is equal to C. Step 2, set it up equations. So one of them is going upstream and one of them is going downstream because returning back is downstream. So we have two cases. So uh, one of them is upstream and then one of them is downstream. So I will look at upstream case and then I will look at what? Downstream case. So here's the case that we have to remember. If it is upstream, you are going against the river, against the current. So the speed of the boat will become reduced by the speed of the current. So that will become my rate for going upstream. When you're coming back downstream, the boat is basically helped by the speed of the boat is pushed by the speed of the currents. So this will become the rate of the downstream. So using this, we can set it up the equations. Going upstream, the speed will be B minus C, right? The boat going against the currents, times with it take 12 hours to travel 120 miles. But when you're coming back, that is downstream, so the speed will be B plus C, right? The speed of the boat is held by the current, times with only 10 hours, that will be equal to the same distance. That's what we got. All right, so it's very important. This concept is very important to remember. Right? 3, solving this. So to solve this, basically, first equation I can divide both sides by 12. The second equation I can divide both sides by 10. That makes it easier for us. And then we got, after we divide by 12 to the first equation, that will be B minus C is equal to 10. And when we divide by 10 on both sides on the second equations, B plus C equal to 12. And you can see that C is opposite coefficients already, so we can use the elimination method to solve this problem, which is 2B equal to 22. So therefore, my B is equal to 11. And the question is asking for both the speed of the boats and the currents. So I'm going to have to continue solving for C. So I can use B plus C equal to 12, this equation. Right? So my B is 11, so I can substitute 11 plus C equal to 12. So my C is equal to 1. So finally, I can interpret it speed of boat in still water is 11 miles per hour, and the speed of current is 1 miles per hour. Okay, so that will be the end of this section.